get started like always. Okay, so today we have been talking about a lot of different things. We talked about things that sink and float. We've talked about, goodness, I can't remember. What else have we talked about so far? Gosh, I lost my list. I'm lost without my list. Sinking and floating. I'm trying to go through my head what we've done. Oh, we did tornado bottles last week, okay? Because we were talking about weather. That's it. Yeah, tornado bottles. Thanks, Zach. I couldn't remember. I was like, my brain's stalling out. It's Monday. Either that or I need more coffee or a haircut. Probably both. Anyway, so we've done tornado bottles. We've talked about sinking and floating. We made penny boats, all of those things so far. And what we're really kind of looking at is we're looking at what's going on in our weather and climate. And last week when we talked that weather is day to day. For example, today's weather, it's supposed to be in the low 80s today. Really nice day. Yesterday it was right around 70, 71, and cloudy, maybe rainy off and on, depending on where you were. Okay, for me, it was a nice cool day. I've been spending a lot of my afternoons, the nice afternoons when it's not raining, I'm putting in some patio blocks, okay? Because I gotta get it done. I don't want a gigantic dirt pile in my backyard. So I know that tomorrow's weather, is it going to be the same as it is today? And I know that no, it's not going to be the same. Weather changes day to day. Climate is over a long period of time, okay? Now I'm gonna go ahead, and I forgot, I need to mute you guys, okay? And I'm not gonna let you unmute yourself today, okay? That's not a bad thing. I just have you guys muted because it tends to feed back my voice. Like I've always told you, it feeds back my voice and it kind of echoes. So when we look at our goal for today we're going to use our knowledge of climate and weather. This should actually be more like weather houses. And we're going to be thinking of what happens when the weather changes, what happens when the climate changes, and how do we build structures that can survive, okay? So last time we talked about climate, oh goodness. Oh, this is dealing with climate season. Oh, that's different. We talked about climate is the average weather over a long period of time. And when we talked about Nebraska's weather, some people said weird. That's fine. Sorry, guys. I think I got a piece of dust in my ear. Give me 1 second. I'll be right back. You ever get that feeling where it's like in the back of your throat and there's like a piece of dust or something? Then it makes you cough a lot. Yeah. Sorry, my voice will be a little weird. It's that weird feeling. So we know that climate is what it's like over a long period of time. In Nebraska's climate, we kind of came up with interesting. We came up with a variety. We came up with changing. Those are all really great words to describe Nebraska's climate, because we know that the weather day to day is never the same. It's not like we're in San Diego where it's sunny and 60 to 70 to 80 degrees most of the time. All right. If you live in a more tropical climate or closer to the equator, your weather day to day is going to be pretty similar. Okay. Yeah, you might have some cooler, rainy days. Yeah, you might have some warmer, drier days. But for the most part, it's going to be warm year round. See, warm here in Nebraska doesn't happen all the time. It gets to be kind of cold sometimes. And the biggest thing we also have to worry about is we're transitioning seasons. We just got out of winter in March, okay? And we're heading into spring right now. Actually, right now it's one of the 11 seasons in Nebraska where it's, no, we didn't get fake summer. We're back in regular spring right now. I don't know if you've ever seen it on the internet. There's a great post somewhere that talks about the 11 seasons of Nebraska. Right now we had a fake spring where it got warm all of a sudden, then it got cold and snowy again. And that was return to winter part 2. And now we're back into regular spring, and then we're going to get into hot and burning, which is summer. And so we divide our seasons based on the amount of light we get and where we are going around the sun. Now, how the seasons line up when it goes to the amount of sunlight doesn't always match where our our meteorological seasons, which we mean that's like weather season changes. Okay, so when we are right now, the equinox, okay, so the change from winter to spring happened on March 20th, about a month ago. So we're right at the beginning of spring. We will be in spring by our revolving around the sun until June 21st. June 21st starts official summer of us going around the sun. But we kind of start summer in late May, early June, because that's when summer starts for school. Okay? Summer technically doesn't end until the middle of September. But we consider September fall, kind of, because our weather starts changing. Winter doesn't actually begin until December 21st, but we think weather, when we talk about our weather season of winter starts usually in mid-late October and doesn't end until like Marchish. See, the difference between how we go around the sun seasons are broken into 4 equal parts. When we talk about our weather seasons, they're shifted just a little bit depending on where you are on the earth. Does that kind of make sense, guys? I'm going to kind of look at you guys. Does that make sense? I see some nods. Good. Okay, good. I'm just making sure you guys kind of understand. And that's just mainly for Nebraska. Now, if we were actually in, like, for example, somewhere like the equator, we really wouldn't see these seasons very much because we'd be getting the same amount of sunlight basically all year round. But if we're up at the North Pole, well, we're going to be cold most of the time, but we'll have days where we have lots of sun, and then we'll have one part where we have barely any sun. And that's kind of weird. If you want to look at something interesting, look at Alaska and the northern parts of Canada and through the North Pole, where they have days where it's 24 hours of sunlight, and then that's usually in the summertime or the summer equinox, or summer solstice, which is June 21st. They have like a day of sun all the time. Crazy. And then you go to winter solstice, and then they have 24 hours of darkness. Crazy. So that's kind of something to look up and talk about and think about. And it's all how the earth is, okay? How we kind of exist on the earth, okay? Now, when we look at weather changes, we talk about air pressure. And right now, we are going to, I wanted to do this one first. I'm sorry, I goofed this up. I made these changes today, okay? This is actually today's actual weather map. No, I found it. Cool thing, you can go to the NOAA and you just type in April 27, 2020 weather map. And this is what you'll find, okay? So right now, we are kind of in this-ish region, okay? All right? So what's going to happen later tonight into tomorrow is you have this area of low pressure, okay? Low pressure spins counterclockwise. Low pressure is usually warmer, wetter air, cooler, drier air, because it's going to be higher up, okay? And it's usually, you see, you have this cold front down here. Actually, no, sorry, it's warmer, wetter air, okay? Because you've got this rotation. Low pressure usually means warm air higher up, cooler air down below, and that usually leads to precipitation. So what's supposed to happen is this cold front will be coming down this way tonight and into tomorrow, which means we're going to be getting what tomorrow, everybody? The thing we probably need but don't really need, going to be getting rain. It's going to rain, okay? So we'll get this first round of rain as it comes down this way, and then tomorrow night it's supposed to wrap around and rain a little bit Tuesday into Wednesday. But then on Wednesday, what's supposed to happen is you have this high pressure area of cooler, drier air, okay? It comes in behind it. And what's supposed to happen on Wednesday is we're supposed to have like 40+ mile-an-hour winds. And the reason we have these high winds is there is a big difference in pressure from high pressure to low pressure. And the bigger the difference, okay, the bigger the difference, the higher the winds are. And that may be a little complex to think about. It'd be like, oh, hang on. Let me grab some here real quick. This and this. And need one other little thing. Oh, this. More of this. All right. So, I've got a whole random pile of stuff. Okay? So I've got 3 books. I've got this gigantic math book. Okay? I've got this small planner, and I've got this small Wings of Fire book. Okay? So, if I were to put these on your shoulders, okay? If I put these on my shoulders, they're basically about the same weight, same pressure, same amount pushing on me. Okay? But if I change this planner out and I put this big heavy book here and I put this little book here, obviously this shoulder here has more pressure on it than this, and I'm going to end up looking like this when I walk, and there's a big difference. Now, if that's air, the bigger difference means high pressure to low pressure. That means air is going to be moving whoosh this way and really pushing hard, okay, like this. All right, I'm going to kind of take a gauge here real quick. Does that make some sense? A little bit, sort of, kind of, little lost? That's good, okay? It's okay to be a little lost on this one. Quick thing, the more balanced our air pressure is, or how hard, remember we did the vacuum bags, the more equal the air pressure is, okay? When we had air pressure like with the balloon, the more equal it is, the more balanced it is, the more calmer the winds are, okay? The more unbalanced it is, the more high pressure I have and low pressure, the bigger difference in strength of the air pushing down, the bigger that pressure, the higher the winds, because it's off balance. Is that a little bit better? That's all you really need to know. As long as you kind of understand that, you'll be okay. All right, I'm not gonna confuse you too much more. This actually really is something that we do more with 6th graders, okay? So here is going to be your challenge, and I'm gonna walk you through it and show you, and then we'll have time to ask questions. This is pretty short because there's gonna be a lot of build time, and the testing is gonna be on your own time as well. Usually what we do, if we were with the 6th graders in this one, we would actually, because they have longer class periods of time, we take about 10 to 15 minutes to talk about seasons and climate quick. And then we would give 15, 20 minutes to build, and then about 10 to 15 minutes to test. But what you can do, because you're at home and you have access to lots of materials and time and the outdoors, and it's windy outside, you can test it, and test it a lot, okay? Feel free to test it. You've got a lot of wind today. Today's a good day to take your climate weather house out and test it today. Test it on Wednesday. Save it for Wednesday and test it on Wednesday and see what happens. Can your house withstand 40 to 50 mile an hour winds, or will it get pummeled? You could even build it today leave it outside, see what happens, see if it bakes, and then leave it, let it get rained on overnight. Then let it get blown over on Wednesday. See what happens. There's nothing stopping. The size, again, up to you. Materials, I'll give you some suggestions, but you can take it from there. There's really no right or wrong way to do this. But I would start small scale testing, and then, like a good engineer, then I would scale it up and try a little bit bigger. Don't go too big because it'll take you a lot of time. So are you ready, ladies and gentlemen? All right, so here we go, ladies and gentlemen. Here's what's going to happen. What you're going to do is you're going to imagine that you're stranded on an island, or you've been dropped into Nebraska, no materials, nothing on hand. Okay, maybe we'll give you a sharp object so you can cut down some trees or some limbs, okay? If this were in 6th grade, we would imagine that we're stranded on an island with a gigantic tarp, some duct tape, and a whole bunch of trees nearby and a sharp object to cut down things. So what you need to do is you need to think of, how do I build a structure? How do I build a structure that's going to withstand as many forces of nature that I can? Okay, so some things to think about when we look at hurricanes. Hurricanes, yes, a lot of wind, but also with it, lots of rain, storm surges, which are big waves of ocean water, big rises and falls. And then finally, sometimes with these hurricanes, they spin up tornadoes. And if they're over water, they call them waterspouts. So some things to think about when it comes to your climate house, okay? If you're going to have flooding rains, okay, and especially if you live along the Gulf of Mexico, notice people build their houses on stilts. That would avoid the inrush of water from the ocean and tidal waves. Probably a genius. Over here, okay, I found a picture of, this is actually along the Kansas Turnpike. They actually have tornado shelters for people that are driving along the highways. Okay, notice they're all underground. They're a safe place. We have basements. Okay, we have basements for the most part, not all of us, but most of us do. We can do that in central parts of the United States. But when you start heading towards the south, like Oklahoma, where they have clay soil, really tough. So they have to have interior rooms. If you think about this, you've got nothing to protect you from high winds and tornadoes, but you're up on stilts in case the stormwater goes in. And then one other thing to think about, look at this roof, okay? It's really steep. And I want you to think for a second, maybe type in an idea. Why do you think you might want a steep roof? What would be a wise idea to have a steep roof? And plus, this is also a steel roof too. Why would that be a good idea? What do you think? I'll keep an eye on your thoughts. Type what you think. Ooh, somebody said snow. That was Josh. Josh, why'd you say snow? Oh, so Ethan says, so the water goes down. True, good. Okay, warmth, water falls off of it. For some other ideas, see what other people think. The water goes and falls off of it. Cold. Creighton says he doesn't know. That's okay. Doesn't matter. Okay. So if I think about it like this, okay, let's say you're sledding, all right? And you have two choices. You have the flat, boring roof, or you have a very steep hill. Which one are you going to want to ride on? A steep one or a flat one? Well, we all know that for great sledding, we want a steep hill. If I want to if I'm in a place where I get a lot of snow and rain, I don't want a flat roof. If I have a flat roof, I get standing water, okay, and it'll pool. And when that water pools, it just sits there and then it seeps into the inside of the building and causes damage. If you have a steep roof, the water and snow run off of it, and then it doesn't stay on your roof, okay? If it doesn't stay on your roof, then it goes away. And then if it's cold, why can't you do flat? Okay, you could do flat, but there's one, it really isn't truly flat, okay? If I had a flat roof, okay, nothing in the world is perfectly level. Even my arm, as level as I'm trying to hold it, isn't perfectly level. I can try, but it's not. You're always going to have a little bit of slope in there. But the problem, if I leave it perfectly flat, and if your land is perfectly flat, you'll notice that low spots or soft spots in it will start sagging and will puddle up, okay? And if it puddles up, okay, so let's say, for example, I'm going to use this tornado shelter. Okay, so let's say that this is flat right here. If it starts to puddle, let's say in this little corner right here, okay, it starts to puddle, number one, it doesn't evaporate very fast. And number two, if there are any holes or any weak spots, the water's slowly going to go down into the structure of the building and then make it weak. If it's on, like my house, that's old wooden house with plaster, it's going to get into the support structures that make the walls, and then it's going to weaken the wood. It's going to cause the wood to rot and collapse, or most of the time it'll harvest mold, which can make people very sick. Okay, so kind of one of those, it's a little thing that's not a problem. Guys, asking questions are fine. It's a great thing to ask questions, always. And you're welcome, Trip. That's okay. You weren't asking any bad questions. It's actually a great question to ask. Why is flat not a great idea? Especially here in Nebraska. Think about Thursday and Friday. I know that I got about a half to an inch of rain. If my roofs were still flat, I'd have puddling and pooling. I have a couple skylights. If the water pooled around those skylights, it would leak inside and it would rot the roof and it would do really bad damage. Okay, as soon as you get water in things, it weakens your structure or harbors really bad molds that make people sick or bacterias. And sometimes you find termites love wet, damaged wood. They'll go after it, okay? Because it's a good harvest plant. So great question. So I want you to think about those things today, all right? So just for fun, I used, and I'll show you kind of how you can test this, all right? I did a terrible job trying to build a weather house. Now, I have my materials here. I have some toothpicks. I didn't use them all, okay? I have some tape that I used. I had parchment paper, which, by the way, does not work really well with tape, just as an FYI, okay? It does not work very well, okay? I have this pie pan right here. So, you know, you want about an inch or so shallow. And while I have a little issue, I built a structure that I am attempting to test. Now, I will be honest. Oh, and I have a Lego guy here too. So the reason I have a Lego guy, so I can see exactly how wet my Lego person gets. I just happen to grab Santa because, well, Santa. All right, so I'm gonna leave Santa right here. He's gonna sit in my structure. Now, if you're building a house or you're building a structure, you probably want a door. I built a teepee, kind of a triangular shape, okay? Building shapes are good. I tried to make this and it won't tape, but I'll be honest, it's pretty terrible, okay? So I'm gonna wrap this here and I'm gonna put this over the top. This is absolutely horrendous. Here, I'll just put that on top. There. Okay, it doesn't even stick. Okay. Here, I'll put a roof, okay? There's my beautiful roof. Beautiful. Look, we'll keep Santa-ish. Isn't it beautiful? It's beautiful. It's terrible. I know. All right, but this will work for what we're doing today. Okay, so what I have done is I have a small thing of water nearby. I'm actually going to go grab one other thing real quick. I had to keep it frozen. So, a couple things. All right, couple things. Yeah, there are a lot of ideas you could do. All right, so in order to make rain, I wouldn't want to necessarily dump this entire thing of water on here. I'd want to make it look more like actual rain. So if I were to make this look like actual rain, here is an idea. Take a plastic cup, okay? Take a plastic cup, absolutely. It is going to puddle. Take a plastic cup and a nail. I actually happen to have what's called an awl, A-W-L, okay? It just has a sharp point on here. Please don't stab yourself doing this. Please don't. And just poke, don't stab down, but very gently, you know, drive some holes. It'd be better if I went this way. Drive some holes into the bottom of your cup. So you make kind of like a little rain cup. And then that way, it doesn't flood right away. Now you can flood it later. You can do all sorts of things. I've got a few holes. Could you use a plastic plate? Absolutely. If you use a plastic plate, I would use one of those. Just the higher the edges are, the better they're going to work, okay? See how I put some holes in there? Not many. Oh, no, bad computer. Okay, notice I put some holes in there. Not many. I'd probably put a few more in there. But for time, yeah. Okay, so I've got a little rain cup. Now, what I can do is I'm going to move this sideways here. And I'm going to show you exactly how terrible this works. I have a towel underneath here. Somebody said this is going to puddle. I'm probably absolutely sure. So here's what I'm going to do. I'm going to hold my rain cup right here above it. I'm going to pour a little bit of water in and then let it rain on top. You might have to shake it a little bit. Notice I have to shake it. Oh no. Oh no. Poor Santa. He's soaked. Poor Santa. Now, when it covers and it doesn't fall apart, it seems to work. Whoever said it was, there, I flooded him. All right, whoever said it was going to puddle, does it look like it's puddling? Yeah, I feel bad for him too. I know. He's probably used to all that snow and water. Okay, so he got flooded. Obviously, this design is ridiculously terrible. Okay, that's fine. Now, we get rain in Nebraska, but sometimes we get hail. Hail is nothing more than, frozen water. So what we can do is, you know, when you rain, maybe you want to have some small ice pellets hit it and see what happens to your structure, okay? Have it fall on top of your structure. Well, that's actually not doing too bad. Oh no, there was a big one there. And maybe you test to see how well it does against, you know, snow, hail, whatever. That didn't do too bad, did it? Actually, that didn't do too bad. It kind of deflected most of it. So, hooray for my terrible design there, I guess. So that's one idea. The last thing you could do, I don't have it with me. Actually, I do. Hang on one second. Actually, I do have a fan. Okay? Hang on one second. Let's see if I can do this without hurting myself. There we go. The last thing you can use is you can grab a fan. All right. Oh, look, I have a fan. So I'm going to plug in my fan. And, well, we can see how well my structure stands up to hurricane force winds. The best way to test that would be to take your fan, put it in really close contact, and see how well it works. Well, it's not blowing away. That's good. Oh, that's pretty good. Well, on the plus side, that was really loud. On the downside, Santa might have got blown away. So those are some ideas. I know that's silly. This is definitely one of the more fun things to do. So right now with this pie plate, what I did is I built it on a small scale. Instead of using toothpicks, if you have like bamboo skewers, feel free to use those. If you would like to try to use duct tape, you can try duct tape. Okay, be careful, it's hard to work with. Okay, don't waste all the good duct tape because that's one way to save the world. Okay, secondly, don't use parchment paper, okay, or baking paper. That it doesn't tape very well. Use wax paper. You could use plastic wrap, but it's very thin and hard to work with. So I would use wax paper. If you don't have wax paper, try something else, okay? Cardstock, regular paper. But remember, regular paper is going to get soaked. It's going to get wet. It's going to be a problem, all right? Otherwise, I was going to build mine up on stilts, but obviously I didn't. You could grab, the best way to do this comically is if you have a leaf blower, see if it blows over, right? There are so many different ways to test this, ladies and gentlemen. There are so many different ways to build it. Usually the tent or teepee idea like this is great. Legos, could try that. Clay, if you have clay and you'd like to test that, great. Could you try to build it from rocks or stones that you have outside? Sure, if your parents let you go play in the mud, build it in like a disposable pie plate, okay? Try Legos. Try to see what things are different, what works well, what doesn't. If you think about plastic, remember we talked about sinking and floating? Some of it works, some of it floats, some of it sinks. Plastic also doesn't let moisture in. Okay, this parchment paper has a little bit of plasticiness or waxiness to it. It doesn't allow much moisture in. So the better you're sealed, the better off you are. The more leaks that you have, the worse it's going to be. You want to try to figure out, how could I survive if I have only a certain amount of things in nature? How could I build a quick shelter? The bigger isn't always better. The more structurally sound, meaning the better you can build it, the more firm it is, the more it doesn't get blown over, tipped over, the more you do that. All I did for my hailstones is I took a couple ice cubes and very gently crushed them in the bag. Okay, if you have crushed ice, fantastic. Have fun with it, test it, take pictures of your ideas, see what you come up with, show me. I'm always for it. All right, so I'm gonna go ahead and stop my